Well, all right. In this video, I'm going to talk to you about the bouncing ball graph that you guys made today in class. So I'm going to be working on this piece of graph paper, so maybe look a little bit different, but my voice will still be there and we'll get things figured out. I sort of also need to use some of my space of the graph, like a whiteboard or a chalkboard. I'm going to write some things down, and in your notebooks, make sure you're taking notes on the things that I'm writing down, but also pay attention to the graph that I'm making. So when we did the bouncing ball graph and you made a table, you ended up with two experimental variables. You had the height of the drop of the ball. So you had the height of the drop measured in centimeters. And you also had the height of the bounce, and that was also measured in centimeters. So as you built your graph, you had to ask yourself, which of those two experimental variables was the one that you controlled? In other words, which one did you manipulate? And that was the height of the drop. So the height of the drop goes along the x-axis, and the height of the bounce goes along the y-axis. So this becomes the x-axis, this becomes the y-axis. One of the things I noticed in people's graphs as I walked around today was you're not being consistent in labeling the lines on your graph. So remember, this is the 0, 0 point right here, and you know that the height of the drop went all the way up to, in most cases, 100. So then you have to decide how much value each of your lines gets when you give them number values for your graph. So if I count here, here's the 0, then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I know that I can count by 5s going across the bottom to get to 100. So my first line would be 5, the next one would be 10, skip one 15, that one would be 20, skip one 30, skip one 40. As I'm doing this, let me remind you that you always number the line and not the spaces. Okay? So I'm going all the way over to 100. Now, I don't know how high your ball bounced, but in some cases, some people's bouncy ball went pretty high. I would suspect that since I used 5s across the bottom, I can probably use 5 up the side, so I'm going to do that. So 5, 10, 15, 20, 30, 40, 50, 60, 70, 80, 90, and 100. In many ways, what I've just done to this point is the hardest part of creating a graph. I've had to identify my experimental variables. I had to figure out which was my manipulated variable that goes along the x-axis, which is my responding variable that goes along the y-axis, and then I had to figure out what value each line in my graph got. So I can also come back and then I can write height of bounce right here, make sure that you do all those kinds of things. Okay? Now, putting the dots on there, that's easy. So like, for example, if I went to 20 and maybe say, I'll just, for kicks and grins, say it went to 10. And I went to 40 and it went to 20. So that number would be right here. If I go to 60, maybe it went up to 30. Okay? And that number looks like it's about right here. Okay, I'm going to make these a little bigger because my graph paper actually had some stuff behind it. 40 or 80 maybe went to 40. Okay? I'm doing this really easily so that I know it's going to match up. Okay? So the other thing to ask myself, because I had this conversation with another student in class, what about the 0, 0? If I drop the ball from 0, how high is it going to bounce? Well, it's not, right? It's going to go to 0. So this really should be a point too. 0, 0 should be a point. So it should come right through the 0, 0 point and then be able to draw a line of best fit. Well, in this case, because of the way that I set it up, it actually was a straight line, and it does hit every single one of those. All right. So this is a graph of the data that we've collected. You should be able to do that on your own. Now, where I want to go to something new is this. I started to do this with some of you in class today, but it's this. We did not drop the ball from 55 centimeters, but we can use the graph to predict how high it would bounce. So I go across the height of the drop to 55. I come up the 55 line until I hit my line of best fit, and then I come across this way to my y-axis, and that's about how high it would bounce. And I'd say, well, that's 20, that's 25, that's 30, that's probably around 28. So if I were to predict how high will it bounce at 55 centimeters, I predict it's going to go up to about 28 centimeters. That's my prediction, okay? So this would be drop here, this would be bounce here, and then that would be my prediction. What if I wanted to predict from 95? Well, I go up 95 line until I hit the line of best fit. I'm going to come across here, and I'm going to say, well, looks like about 47 or something. Okay, so 95 centimeters might be somewhere around 47 centimeters is my predicted bounce. Okay, so that's how I can use a graph to not only represent the data that I have collected, but also use it to predict what other, if I wanted to predict another data point, then I can do that using the graph. So what I'd like you to do for next week is to redo your graphs. I want to see a really, really, really good graph. I have put a link to graph paper on the course, so be sure to use that. So everybody needs to come with a new graph that is completely labeled with your x-axis labels, your y-axis labels, has a title on there, and it's got your line of best fit. All right? Make sure, because I'm going to look next week, make sure that the spacing, the way you've numbered your lines for each of your graph, for both your x and your y axes, are done the way that I just talked about. Okay? If you have any questions throughout the week, please let me know. Just send me an email, and I'll take care of them. Thanks, you guys. See ya.